be solving about how after creating open 4 squares here, and then we bend the sides, and then we're supposed to figure out the maximum volume. Now, suppose that these little squares are cut, and suppose that these lengths are called x. Now, the width of the cardboard is 8 inches. Therefore, we will create the length here, which is going to be the base. And remember, this is the base of the box, so the base times the height will yield the volume of the box. So then the length here, or the width here, will be 8 minus 2x, because the original length here is 8. There's b minus the 2x's, and that's the same thing for here. Is that the length is 16, but then you want the length here, because then that'll be the base that you can later multiply by. So then you'll do 16 here, and there's 2x's on the side, so you minus that by 2. So you subtract those. So it'll be 16 minus 2x. Now, notice that here, this length and this length are the same. So this is L, and this is width. In order to find the area of this, the area is length times width. So the area with respect by representing in terms of x will be length times width, or 16 minus 2x times 8 minus 2x. Okay, that's the area of the base here. And now we just have to multiply it by height. Now, what's the height? Well, try to imagine it, try to think of it visually, is that when you try to fold all these, the length here will be the height. So that will be x. So therefore, since volume is the area of the base, which is a of x, times the height, so therefore volume will equal the base area here, times the height. Now, notice that this x, we can simplify. So we could just distribute the x into either one of these. For here, we're going to distribute the x into a minus 2x. X times x. All right, so now we have a volume equation here. If you wanted to know the maximum volume, which is literally written right there, then that means that now we're going to have to figure out the maximum volume by finding okay, so in order to find the maximum volume, right, and pretend that this is V, it will look like that and that, right? So then you will get a maximum if you get the derivative here as does not exist or 0, so d and e, or 0. Oh, and this is not dive, it's just d and e. And this is when the derivative does not exist or when it equals 0. And then when before that the derivative is positive and after that the derivative is negative, then you have a maximum there. Okay. And so yes, so then now we're going to take the derivative. So then when you take the derivative, or before you do that, let's expand this equation here. Then it'll be easier to take the derivative. So then by expanding it using the FOIL, then you will get 128x minus 16, no, minus what? 48x squared plus 4x cubed. Okay, so this is the volume of this function. I just merely expanded it by FOIL. If you were to take taking the derivative of that will yield now you get this derivative. Further simplifying it, we yield, let's see, if we just factor out everything by 12, then you could get 12 x 8x, and then 12 divided by, so then that would be, well, I'm gonna continue this under the written responses. If you have any questions, comments, or concerns, any feedback would be highly appreciated.